This demo showcases how SIMbae removes the complexity of SIM development, allowing anyone to create, configure, and deploy custom applet logic at scale without writing a single line of Java code. Hello and welcome everyone. We start by showing the node editor on the left, and on the right, you can see the mobile phone mirrored to the computer. This phone has a SIM with SIMbae installed. It's connected to the network. Now I'll show you the SIM Toolkit menu. SIMbae is installed here. For our demo, you'll see the user menu is currently not doing anything at the moment. In this session, we're going to show how to create a script with the node editor, how to edit it, and how to upload it to SIMbae. Let's get started. The first script we will demonstrate is a very simple one. When the user menu is launched, we want to show a single Hello SIMbae message on the mobile phone screen. Scripts consist of events and actions, and in this example, we can see a single event, which is user menu launched, connected to a write custom message action, set to show Hello SIMbae on the mobile equipment. I can easily drag and drop the script where I want it. As you can see, the user menu is not doing anything when I click it. After I click upload, you will see that this script is compiled first to a Python format. The Python script is converted to binary format. The binary script then is uploaded to SIMbae using a TCP connection. As I click user menu now, you can see it's already writing Hello SIMbae. I'll now demonstrate how easily we can make another change. I'm going to change this message to Welcome to SIMbae. I'm going to click Upload. After I click OK, I will now go to the script upload screen. This script basically has one user launched event and one action associated with it, which is Welcome to SIMbae. The new script is already sent successfully and installed seamlessly on SIMbae. As I click on the user menu, you can see it now shows Welcome to SIMbae displayed instead of Hello SIMbae. It is now time to show you a more complex example. This time, we want to instruct SIMbae to send network information data periodically. We call this our Find It use case. Using the node editor, I am now scrolling down to find the timer. This timer box has 30 seconds and 0 jitter. I'm going to need the timer events, so I'm going to need to know when the timer is expired. But we also need to start this timer, so I'm going to start this timer right when the script is already loaded. I'm also going to need to connect to the timer expired to the timer start, so that this is a recurring timer. Otherwise, it would be just a one-shot timer. Next, I can also link other actions to this time expired event. I'm going to scroll down to network information related actions. First, I'm going to grab the network information actions box. I'm going to update the access technology, a prerequisite to obtaining network measurement results from the device. I'm also updating the NMR, allowing SIMbae to update the perceived signal strength and other metrics. And finally, I'm going to need to send this information back to a server. So I will now enable the function of sending the location and the NMR data. This basically is our Find It use case, easily configured using SIMbae. After I click Upload again, this whole new logic will be loaded into SIMbae. As you can see, it is a much more complicated script. For an easier view, I also will show this to you in VS Code window. This is the same script, but formatted in a way that is much easier to digest. We can see there are two event and action pairs here. First event is when the timer number 1 is expired. We see update access technology. We see updated NMR. And we see a lot of variables sent here, like MCC, MNC location area code, the signal strength, signal quality, and so on. We can see another pack here, so when the timer is expired, or when the script is loaded, we restart the timer with 30 seconds duration. If I go back now, we can already see the location, and NMR data is being sent here, so this location, NMR, as seen in the script, is visible. There's a couple of metrics here, and if I go to this other screen, we can see that the signal strength is indeed updated. We can see the live data coming from our script visualized here. If I go to this other application called NetMonster, which is basically an Android native application, we can validate that the RSRP value displayed there is the same as the RSRP value perceived by SIMbae. This concludes the demonstration. As you can see, it's very easy to just chain together custom logic and change how SIMbae behaves entirely using the node editor. SIMbae allows anyone to create, configure, and deploy custom applet logic at scale without writing a single line of Java code. Thank you for watching.